For our first slide, I am going to give you a brief introduction about our assignment. So, the topic that we've chosen is loan default prediction, which is a domain of finance. Our goal is to predict whether a loan applicant will default, fail to repay the loan based on their financial and personal attributes. Our background contains detailed loan record, including the borrower demographics, financial history, loan amount, and interest rate to default or to be paid. This predictive model helps lend assess risk, streamline, and decision making for our models. So here is our assignment objectives. First is to evaluate our multiple data mining techniques for loan default projection. And second is to select the most appropriate technique for this domain. And then we assess those domains into a dataset readiness through the pre-processing and feature selection. And then finally justify and then address ethical trust and concerns for implementation.
Is sourced from Kaggle and is titled the Loan Default Prediction Dataset. Originally derived from a Coursera project, it contains over 255,000 records and 70 attributes, including financial and personal details such as income, loan amount, employment length, credit score, and loan status. The target variable is default, which indicates whether a borrower failed to repay their loan. This dataset is highly suitable for classification tasks as it is large, well-labeled, and provides relevant features that reflect real-world financial behavior. The ultimate goal of using this dataset is to develop a predictive model that helps financial institutions assess the risk of loan default before making approval decisions. Summary of the attributes process in orange. The dataset involves a binary classification problem where the target variable default is defined as 1 for borrowers who defaulted on their loans and 0 for those who did not. This clear distinction allows classification algorithms to differentiate between high-risk and low-risk applicants. We began by filtering out less relevant features and selected meaningful attributes that had predictive value, including both numerical data such as loan amount, income, and credit score, as well as categorical fields like employment type and loan purpose. These attributes were cleaned, converted into appropriate data types, and then fed into various classification models to evaluate their ability to predict loan defaults accurately. In total, we worked with a filtered set of the most relevant features, enabling efficient model training while maintaining high predictive power. Loan default, we experimented with 3 classification techniques, which is random forest, logistic regression, and decision tree. All models were evaluated using cross-validation and performance metrics, including accuracy, AUC, precision, recall, and F1 score. Although logistic regression slightly outperformed AUC during this experiment, it is important to note that the dataset was downsampled to 10% for practical processing in orange. With larger datasets, random forest typically performs better due to its assembled nature, which increases predictive strength and reduces overfitting. In our test results, random forest showed consistently high accuracy and F1 scores, indicating a solid balance between precision and recall. It also performed best in terms of the MCC, which is especially valuable in handling class imbalance. Therefore, random forest remains our top recommendation as the most robust and scalable technique for real-world deployment in financial loan risk prediction.
I will justify why we choose random forest for our method. The strength is high accuracy and handles missing data very well, more than logistic regression. And their limitation is to less iterable, lower than simpler models than other models in the list. And then lastly, it is suitable for overall accuracy, stability, and real-world complexity. Slide, I am going to discuss about the data processing that we have managed. The first is to handle the missing values in the dataset. Fortunately for this dataset, there are no any missing values, and we only had to normalize the features, which is the normalized to interval, which is 0 and 1, and then impute the missing values, which is the average and most frequent. For our feature selection, we have been using the orange software by using filter methods in our dataset to each feature independently and provide scoring methods including information gain ratio, Gini, and chi-square test.
We continue with stakeholder trust. For the stakeholder trust, to ensure trust and confidence among key stakeholders such as bank executive, credit analysis, and regulators, the random forest model was used because of high accuracy and ability to highlight feature importance. The model was evaluated using metrics like accuracy, AUC, and confusion metrics, providing objective of its performance. It is recommended to include performance audit and regular training schedule to maintain transparency and accuracy. Additionally, human in-loop approach is encouraged in critical or borderline decision to ensure fairness and contextual judgment. Ethical consideration. To ensure ethical use of the model, several key action was taken. Transparency was prioritized by selecting features that easy to interpret and by recommending the use of explainable AI tools where possible. Data privacy was maintained through anonymization and secure handling of all sensitive personal and financial information. To prevent bias or outdated prediction, the system includes regular model monitoring and performance audit. Finally, all data used for modeling was either public, available, or obtained with appropriate usage right. Move on to result and impact. For my justification for the random forest, it is most suitable classification method for this project for ability to handle large data set, which is about 25,000 samples and diverse data type, including missing values, categorical and numerical attribute. Random forest reduce overfitting by constructing multiple decision tree and aggregating their result. And their advantage is to perform feature important analysis which allows stakeholder to identify and understand the most influential factors contributing to loan default. And as you can see at the result from this data, random forest achieve accuracy of 88.4%, which nearly identical to logistic regression. However, random forest outperformed in terms of MCC, scoring 0.118 compared to 0.035 for logistic regression, indicating better balanced classification performance, particularly important for imbalanced dataset like loan default prediction. While loan regression recorded higher AUC score, random forest was chosen due to its consistency, stability, and real-world applicability. Conclusion. Random forest show the best performance for predicting loan default. It handle different type of data well and provide high accuracy. The model help identify key factors like income and credit history, making decision process more transparent and reliable. For recommendation, we recommend using random forest model in loan approval process to support decision making. The model should be reviewed and updated regularly to ensure it stays accurate and fair, showing which features more important can help build trust with stakeholders. That's all for me. Thank you. Conclusion.